All right, so this is the review that we just finished, and I just wanted to go over it really quick with you guys before you leave for home. We have about 20 minutes. Hopefully we'll get it done in that time. But number one, it's give the equation for the asymptotes of the graph of the function of h of x is 1 over x minus 7 minus 9. So what are the asymptotes of this? First of all, tell me what the parent function is. 1 over x, okay? And where does it move? Seven to the right and down 9, right? Okay, so that being the case, what is our x and y equations going to be for our asymptotes? Not negative. Yep. Yep, so it should be B. Okay? Number 2 says, let the translation be x plus 4, y minus 7 to be applied to the quadratic equation. Write the equation for the image. Okay? So, first of all, we're going to take this y equals x squared, and it's being minus 2, so we're going to do the opposite of that, so it should be y plus 2 over here. This is a plus 4, so it's going to be the opposite of that, x minus 4 squared. And then if we solve for this, it could be y equals x minus 4 squared minus 2. So which one of these equals what I just wrote up here? C. All right. Number 3, using the information provided in number 2 above, what are the coordinates of the vertex in the image you chose? Where's the vertex? Well, you can even just find it by looking at this equation. It's right here. 4, negative 2. So that one is D. Because this is in vertex form already.
Why wouldn't it be negative 1?
Because remember, it's the opposite.
Oh, okay. For just the x then?
Yeah, on the x when it's solved like this. When it's solved like this, it's opposite for both. Okay? Number 4 says the graph of the function f is given below on the left. Which of the graph choices available is the proper graph of the image of f under the transformation of 2x and negative y? First of all, what happens in the x component? What's that 2 do to it? Nope. Yeah, so this is a horizontal stretch of 2. And then what happens to the y? Yeah, it flips the y, okay? Okay, so that being the case, it's going to be going the opposite direction of this one, right? So we know this is not it, because that's going in the same direction. It's going to either be B or C based on this, and since it's a stretch, which one do you think it should be? It's B, because look at the coordinates on this. This is to the 8, this one's to 4. Okay? So it's going to be B, even though it looks like it's not a stretch, but you got to make sure your coordinates are this, the difference. All right, so that is number 4. Number 5. Suppose a chemistry student finds masses of different samples of potassium chloride and subtracts 150 from each value before computing the statistics. That's important information. You might want to underline that when you see it. Subtracts 150. The mean is 4.2. The minimum, 0.4. The median, And the standard deviation, the max. Quartiles are here. For the actual samples of masses, give the median. So what do we need to do? Okay, so we're going to add 3.8 to 150. So that will be B. Okay? Give the range. How do we find the range of a sample of these?
Is it like the first and last?
Yeah, so the max minus the min, right? So it'll be 13.6 minus 0.4. Okay? So that should be 13.2, and just because we added numbers to it, it doesn't change the range. Remember, when you add or subtract to all the statistics, the range stays the same. So this will be this one. Okay? We're at... Okay, so give the IQR. How do we find the IQR again? It's going to be quartile 3 minus quartile 1, which is 4.6 minus 3.6. So it's just going to be 1, and we don't change that at all with this because adding the same value to each statistic doesn't change the interquartile range either. Okay, so number 6. We have, suppose a chemistry student finds masses of different samples of potassium chloride and subtracts, this is the same kind of thing, subtracts 150 from each value before computing the statistics. So now we have these. Okay? For actual sample masses, give each statistics from 5 in ounces. So we're going to change this from grams to ounces. What do we have to do to the median? What are we doing to the median, you guys?
Is it, no, you're going to multiply by 0.4.
Yep. Okay. So if the median, you're going to add that to 150 again, so you have 153.8. You're going to multiply it by 0.035. Yep. They should have gotten B. Okay. Give the range. Well, if we go back to what we saw, what the range was before, the range was on the page before this was 13.2, right? What am I going to do to that range? Multiply it again by 0.035. Okay? You should have gotten 0.462. Okay? Same thing with the IQR. We had 1 before. So if I multiply that by 0.035, I have this. Okay? Okay, so number 7 says, let f be a real function with f of x equal to 4 the cube root of x plus 1. Find the equation of the inverse of f. So what we are doing on this one, you guys, is just changing the x and the y. So this will be x equals 4 cubed root of y plus 2. So what's the first thing I need to do to solve for y? Divide it by 4. Okay, so it'll be x over 4 equals the cubed root of y plus 2. Now what? Cube both sides, right? So that's going to be x to the third over 64 equals y plus 2, because we're cubing both sides. Now what? minus 2. So that one will be B. Yep. All right. Any questions on that one?
So when it's asking us to do that, do we have to do the whole process?
Yeah. Okay, sketch the inverse of F. Okay, the inverse of F should have been B. Okay? One of the things you guys can do if you have your, oh, sorry. Is it a function? Yes. Okay, well, here's the reason why. If you look at the inverse of it, here's the inverse of it right here. It passes the vertical line test. Okay? You can use your graphing calculator to graph it and check it. Okay, oopsie, I went too far. Number 10. Let m and n be real functions where m of x is 16 minus 5x and n of x equals x plus the square root of x. Write the expression of n of m of x. Okay? So, basically, I'm going to do this down here. We want to put into m the following. Oh, shoot, it stopped working on me. Okay, so we're supposed to do this, n of m of x. So we're going to take m of x and put that into n. So that'll be n of 16 minus 5x. So that's going to be 16 minus 5x is replacing the x value, plus the square root of 16 minus 5x. Okay? So which one of these is most like that? B. You can't even put them together. There's nothing you can do to put them together, so you can take the parentheses out. That's about it. Okay? Using the equation from 10 above, give the domain. So what are the possible values of x here? It could be all real numbers, and what else? Yeah. But what does this tell us right here? What do we know about the square root? Can that be negative? Okay, so this number inside the square root has to be bigger than 0. So let's find out what that number is. It has to be greater than 0. Okay? So if we solve for x, we got minus 5x greater than negative 16. Because I'm subtracting 16 from both sides. Then I divide both sides by a negative 5. Okay? So 16 divided by 5, I'm just going to leave it like that. It becomes a positive. What happens when we divide an inequality by a negative? It changes direction. So it's this. Okay? So we know it needs to be all real numbers that are less than 16 fifths. Okay? So it should have been this one. I would have liked for the answer to have said all real numbers, like how I like doing it, like this, and x less than 16 fifths. But it didn't have that, so. All right, so now on to 12. Number 12 says, suppose the scale change is 3x and y divided by 2 is applied to this. Okay? Write the equation for the image. So remember, it's the opposite of what this says. So my y is going to be what on this? 2y. And what's my x going to say? Yep, x over 3 squared. Okay? So that should have been A. Number 13. A data set has a mean of 83 and a standard deviation of 7. What transformation should be applied so that the image has a mean of 0 and a standard deviation of 1? The answer should be B. Okay. So, first of all, to get the mean to be 0, you're going to have to subtract 83 from each data point. Okay? And to get the standard deviation to be 0, you need to divide it by 7, so there is no to standard deviation of 1. You need to divide each data point by 7, so it'll be 1. Kind of, yeah. Kind of like the z-score thing. That one was a tough question. Okay, number 14. Tell whether the function f with the equation is even or odd or neither. So how do we do that again? Yeah, we're going to put in a negative x. So this will be negative x squared minus 5. This becomes x squared minus 5. Did it change at all? No, so what is it? No? It's even. If it doesn't change at all, it stays even. Okay? If it changes to all of it being negative from what it was before, it's odd. And if it's neither... Okay, so let's do this for... Hey, let's try this one, guys. What is this one? If I have x to the third minus 5. Okay, so if I put in a negative x to the third minus 5, then this becomes a negative x to the third minus 5. Now, is that completely opposite of what it was before? It isn't. So which one is it? This is a neither. In order for it to be odd, it should have been negative x to the third plus 5, which is opposite of what this is, right? Okay. Number 15. The graph of the function g is an angle. What is the parent function of this? Yeah. Yay. That's it. Absolute value. Okay, 15b. Using the same graph, find the equation. Okay, so now is this, what happened to this graph? If the original goes through like this, yeah, what got smushed? The y's did, didn't it? Okay, so it got smushed by half. Yep. 15c, use the same graph. What symmetries did the graph has? The y-axis. The y-axis is its mirror, right? So it's going to be that one. And give the range. What are the possible range of this absolute value? See, it has to be greater than 0, right? Okay? 16. Give the rule for the reflection over the line of y equals x. This, you know what they're actually asking you guys? It's D, actually. They're asking you, this is saying, what is the inverse? I know, isn't it? I don't know. I don't remember seeing that one either. But the reflection, remember reflection, the inverse is always over that line, right? If we fold on that diagonal. Number 17. Suppose a population of mice have a mean weight of 30 grams and a standard deviation of 3.4 grams. A population of moose have 910 pounds and a standard deviation of 185 pounds. Which one has is heavier relative to its population? So we're going to find the z-scores. So the first one is, here's our first mouse. It'll be 37 minus 30 over 3.4. And then the moose is 1260 minus 910 over 185. Okay, what did you guys get for these two scores? 2.0 for this one? Okay, what'd you get for the other one? 1.89. So which one has a bigger z-score? The mouse. So that mouse is like way bigger than all of its fellow mice. Okay, as a real quick add, we just were talking about this one on 15B, because this has a vertical stretch, or not vertical, horizontal stretch of 2 on this one, and a vertical smoosh of 2. So this would be like saying y equals x. So because it's shrunk vertically by 2, that is going to be listed as the opposite. So it'd be y over 1/2. And this one is, because it is stretched, it's going to be x over 2. But if you notice this y over 1/2, that is the same thing as saying 2y, like this. So both of these right here are also, they're the same. So either, if you got either one of those, you should have had the right answer.